Hello everybody again and go from 0 to 1. This is the second lesson in variables. So let's start. Okay, I need to show you something. Okay, let's say A var B bool var C byte. Okay. Byte is just a name, and it is name for U integer 8. Okay, so it's U integer 8, and of course its size is 1 byte. Let's print it, the size. Size of A, size of B, size of C. Okay, it should be, this is 46, so 8 bytes, then 1 byte, then 1 byte, 811. Okay, that's right. Second thing, I want to print addresses. Okay, A, B, C. Okay, the first one A, this is the address. Let's focus on these two, okay, because the others are same. This is 48, the address 48. Then here we have 50 and we have 51. Okay. This is an hexadecimal. We need not to forget this. So 48, it goes from, okay, is my Stixify. It's 48, then 49, then not 50. Okay, what is it? It is 48. Okay, 4B, 4C, 4D, 4E, 4F. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's 8. That's true because this is 64 bits, so it's 8 bytes. So it takes the addresses from 48 until to 4F. That's right. So the next one is B. Its address is 5. That's very good. The second is C, and it's the B is 50 and C is 51 because this is just one byte, takes just one byte. So the next will be in the next byte. Okay. Now I need to talk about word size in computer systems. Okay, and it's related to memory, of course. Okay, the word. Okay, we know the bits and bytes, but what's the word? The word or word size is the maximum number of bits that the CPU or the computer can handle in one time. Okay, for example, can read word size, can read number of bits equals to the word size once from the memory and write them to the memory, load them to the register, write them or make operations on them. Okay, and word size is depends on the machine architecture. So in machines with 32 bits, the word size will be 32 bits. Machines with 64 bits, it will be 64 bits. So my machine is 64 bits, and the word size will be 64 bits, okay, or 8 bytes. Fine. If we see this here, this is 16-bit data memory RAM. Okay, 16 bits means that this is the size of word. Okay, if we see this is 800, this is 802, whereas 801 it's included because it is 16 bits and this is by byte. So 800 and 801 together combines the word, okay, here. But we can access each byte individually inside the word, okay? The word is just okay, it's not more it's more than logical. It's not just a logical thing, but okay, it's physical and logical, and also so we can access it or read this size of bits, the word size of bits, which is could be 64 bits once a time, and in the same time we can read just a byte. Okay, we have two choices. We have this flexibility. So here's this is word, this is word, this is word, this is word. But even the bytes inside the word is are accessible. Okay. Now let's see what I will do. Okay, I will take this and define. This is what I want you to understand. Okay, I will put it here. Okay, and let's see the addresses. Okay. Now what we have this the first. Okay, this is not the first one. So let me rearrange them. Okay, this is the first one is 1 byte and its address is 42. Fine. The second one, okay, the one B is 1 byte. So we suppose that the second one will be 43. B will just take 1 byte and the next it just become and start from the next byte. But this is not true. Why? Okay, B is 42, but A is 48. Okay. If we see from 42, 42, 43, 44, 45, 46, 47. Okay, this is what it takes. And this is started from 48. Okay, 1, 2, 3, 4, 5, 6. Okay, this is 6 bytes. Okay, 6 bytes. All this, okay, I suppose, and of course, this what should be that 42 is not the beginning of a word. Okay, it's the third byte in the word. Okay, so we have this 1, 2, 3, 4, 5, 6, 7, 8. Okay, yeah, we need another 2 bytes to combine the word. So this is the third one. Okay, this means that the word become at 40. Okay, but our boolean variable starts here. Okay, so all these bytes are not used. Okay, are not used. Why are not used? Because variable a is needs 8 bytes. Okay, and 8 bytes are the word of the size of word. Okay, so it cannot start from even from the second byte in the word. It must start from the first byte in the word and goes through all the word. Okay, so it must become from a new word and take all the size of this word. And this word, first byte address is 48. So at 48, our our A variable starts. Okay, A variable starts at what? At 48. Okay, so these all these variables, not variables, bytes are not used, and this is a waste of memory. Okay, if we see this one, this must be start after this with all bytes, with 8 bytes. Okay, so we have okay, for 48 from here we have all of this, of course, and this begins at 50. I hope this is clear. This means that when we declare or define variables, we need to take care about their orders in definition or in the declaration, okay? Because not compact orders, this is not compact declaration, okay? But now they are compact, okay? So what it needs, the whole size of word, let us the start one, okay? Starts with him, or in fact maybe the last could be the last, because in fact here the first one, this was not in the first byte of word, it was the third, so we can save this word before we define this a. Okay, so orders of declaration of variables, it depends on the size of variables, okay? So we can make a compact declaration like this and not waste memory, okay? So let's combine the biggest together and the smallest together, okay? These are, each one is 1 byte, and this is not 8 bytes, okay? Also, if you have a d integer or integer 64, same. If we say there is d, you will see some gap from them, of course. So c is 1 byte, starts in here, okay? Let me do this to be clear. Okay, alright. Okay, this is A is 64. Then we have 1 byte is B. Okay, and the second byte of C. Yeah, this is C is 1 byte. 1 byte here, of course, 1 byte here. Okay, after this we jump. Okay, we jump, but how much we jump? Of course, it's not always 8 bytes. 8 bytes, of course. We have 59. Okay, 58. If A, if B, if C, if D, if E, if F, then we get 5. Okay, 50, I mean. Okay, so we have this one, we have all of this. I'm not used, but okay, but this is better than, but do you know what? No. It's 50. I have, yeah, this would be 60, not 50, yeah, because we defined them. So this is 48. Okay, this is starts with 48 here, 48, tick, all that, then we started with 50 here. That's right. Okay, so A and D, there is no waste bytes between them, and they take all the word size, each one take it, and this is, then comes next it. Okay, this is, and this is first, this is comes next it, and then this is, and then this. Okay, so I hope this is clear. This compact declaration about variables, it could be, if you have a lot of variables, of course, you need to take this in consideration, but if they are some variables, not a lot, okay, and you have a lot of memory, don't care about this, but this is a very good information to understand and keep in mind. Okay, so let's return to variables in Go. Okay. Now we know that A and D here have the same size, right? Yes, of course they are 8 bytes. Let's say var D equals A plus, okay, not D, of course, B. C, okay. This is for invalid operation. A plus D mismatched type is integer and integer 64, okay. So when we deal with multiple data types or variable with different data types in one expression, they cannot combine them in like this. Okay, we need to convert from one type to the other type or vice versa, so our expression can be valid. Okay, see, there's no problem about C, but this is the problem. Okay, we know that they both 64 bits, but logically they are not the same type. Okay, this is integer, and this is integer 64, and the compiler says they are different. Okay, so we need to change type from one to the other one. Okay, let's say integer 46 for A. This is called casting, but what's the problem here? Undefined integer 64. Oh, reference integer 64. Yeah, of course, it's 46. Okay. Okay. This is casting, which affect this parameter, this variable is, I cannot say this is a function, it's not a function, okay, it's type. So we say type and parentheses, and we have another data type, it converts this from this type, its type, from its type to this type, okay. So now both of them are integer 64, and of course C here becomes 64, integer 64, and there's no problem about this. Okay, of course we can do the opposite. I can say integer here, and of course it's okay. Both of them are integer, okay. But let's say, not take, okay, let's keep it, whatever is, let's say 1, 2, 3. There's no problem, okay. Why? Because this is a literal, it's untyped literal, let's say, they call them Golang untyped literal, they don't have a type, okay. So when we add them to another type, there's no problem with them, okay. We don't need to change them to the other type, okay. Okay, let's assume what is going on here. Okay, this is integer 64 and this is untyped, okay. The compiler can change this implicitly to integer 64, but in fact, what I suppose is not this, is like, let's say this is 1000. It's like compiler put here 1000 instead of D, and now both of them are untyped, but of course they can be evaluated. Okay, I suppose this, I'm not sure about this, I don't have any information about this. If you have any information, please write it in comments. Okay, now, okay, this is how we declare a variable. We have another one, short declaration, so we can say cd, let's say e equals to 125. Okay, we just need to delete this here. Where are we? Okay, fine. Now, okay, so this is declaration and initialization in one statement, okay. This is called, of course, type inference, but the compiler knows what's the type of this value and put it and define a variable with the name A and with type of this value, the same type, and store this value inside this type, okay. We know the type of this is integer, of course. We can now printf it with verb t and e. it will print integer, int. Okay, so this is the short declaration. It's commonly used in Go, but we cannot say this here. Okay, this doesn't work here. It works inside functions and methods only. Okay, here we can say var if equals string. There's no problem. Okay, another thing we can do to define variables is like import. We see import and open this parenthesis. Okay, I can say g integer h string eyeball whatever. Okay, in one statement var parenthesis and each one with its type ij. Okay, how much we need in one line we can. Okay, and also we can give him a value. Okay, but this is the sequence. Okay, this is in the first I, false in J, and true in K. Of course, this is not just for this var declaration, also for here. E. Okay, it doesn't work. Okay, I knew it. Yeah, it works. Oh, I used everywhere. Okay. Fine. We can define them with time inference in one statement shortly with this. Okay. So this is about variables, and we talk variables casting. Okay, from integers to another integers or float. Okay, let's see for floats. Let's say okay if equals 1.25 and I want to print summation e plus f. This won't work, of course. Let's remove our e. Okay. Now, okay, we convert f from its float 64 to integer. This will not round it, if we see, but we'll truncate it. We'll truncate the decimal point. Okay, we'll not round it. If I say println f, it will give me 1. Okay, this is the result even if it will be rounded, because 25 will not round, but let's say 95 or so on. So it's just truncation. Okay, it is not about rounding. I suppose here round. Okay, now we have round. Okay, so this will be 126, will be 127. Okay, it's not. Yeah, because I didn't do it here. After rounding, okay, let's see, round will float 64 and this is integer. Okay, I can convert this one. Cast it from what's my type integer. Where is the float? 64. Round returns float. You round it, why you returns as float, I don't know. But okay. Because I suppose when you round the float, it becomes integer, of course. So why it's still float? It's their decision, not mine. Okay, now round it to 2, and 2 plus 125 is 127. Okay, so this is conversion from integer from float to integer, and of course the vice versa, the object could be, let's say this, a float. Okay, we convert the integer to float. It's like 125.05. Okay, of course the same result, but now it's a float. It was integer previously when we convert both of them to integer, but now it's 127 the same, but here it's a float. We need to consider this. So this is now for variables. Thanks for watching.